So we were in section 4.1 looking at divisibility in modular arithmetic, and we had defined what it means for a number to be divisible by another number. We looked at something called the floor function, and we had used that to solve certain problems. Let's say, for example, let's find how many positive integers are less than or equal to a particular number and divisible by another number. We did problems like that using the floor function. So we want to get into something new here. We want to do something called the division algorithm. The division algorithm, it's basically basic division that you would have learned probably in second or third grade. And the statement of the division algorithm, it's actually a theorem that you can prove, but we won't prove it in this class, as this class is not a proof-based class. If you take Math 411, which is the introduction to modern algebra, you'll do the proof for this theorem in there. But it says the following. The division algorithm says, let's suppose you have an integer a and a positive integer d. So a is an integer, d is a positive integer. Then, if that's the case, there are unique integers, q and r, such that a equals dq plus r with r greater than or equal to 0 and less than d. So there are two important things going on here. Number one, we have a equals dq plus r. So that's an important equation for the division algorithm. And the second thing I'm going to highlight here in blue is that this r, that's called the remainder must be greater than or equal to 0 and less than d. D is going to be the divisor. So what's actually happening here? So the idea is we start off with this a, and we're going to divide d into it. I have a little division box. So up top, we're going to have our quotient, q, and basically what happens is you take q times d here, which will become dq, and you subtract, and a minus dq is going to give you your remainder r. So if you actually pay attention to our blue equation, right, if I were to subtract dq from both sides, I have what? A minus dq equals r, right? Precisely. That's what that equation is saying up top. A equals dq plus r is the same thing as a minus dq equals r. That's what we did, right? We take the red a right here minus the dq, and we got our remainder, r. So that's basically a really basic division that you would have learned in second or third grade. So what is a called? A is called the, I don't know if you learned this when you were back in second or third grade, but it's called the dividend. D is called the divisor. That's what you're dividing into a. D is being divided into a. Q is called the quotient. That's the number of times, if I can spell quotient, the number of times that D goes into A. If I can get this to right. And R is called the remainder. And sometimes you have a remainder of 0, right? Look at that inequality back in blue, right here. It's inequality, right? Sometimes the remainder can be 0, but it's always greater than or equal to 0. It's never negative. You never have a negative remainder. And it's always strictly less than the divisor D. That's important. All right, so let's use the division algorithm to work some problems. Okay, so examples. This to work. You want a calculator for this type of stuff. Use the division algorithm. To find Q, the quotient, and R, the remainder, when the following happens. Let's say A is 20 and D is 3. So we're going to take 20 and divide 3 into it. So 20 is divided by 3. So again, the A here is 20. That's called the dividend, and D is the divisor, 3. Remember your formula, your equation is A equals DQ plus R, right? That's the division algorithm equation. So we're going to start with A, which is 20. And we're going to do D, which is 3. We have to find the Q and the R. The Q and the R. So what I'm going to do, I'm going to take my calculator and I'm going to take 20 divided by 3. 20 divided by 3. And when I do that, 20 divided by 3 is going to give me like 6.6 repeating, right? 6.6 repeating. So for the Q, I'm going to put 6. I'm basically using the floor function here. So I took 20 divided by 3. I got 6.6 repeating. I used the floor function. And my quotient, Q, is going to be 6. And then we're going to take 20 minus 3 times 6 to get the remainder. What is 20 minus 3 times 6? Well, that's 20 minus 18. That's a remainder of 2 here. That means our Q is 6, and our remainder R equals 2. Now, something you should always check here, you should always check that your remainder, remember this inequality here? Your remainder is always greater than or equal to 0 and less than the divisor. So notice that the remainder R is 2, right? It's greater than or equal to 0, and it's strictly less than the divisor being 3. It's important. Always make sure it's less than the divisor. Okay, so we found the quotient Q, we found the remainder R. That's what we're asked to do. So 6 and 2, those are our answers. Q and R, 6 and 2. Well, let's do another, number 2. Oh, I don't know what happened there. Can we go back, maybe? Don't know what's going on with this dude. So use the division algorithm to find the Q and the R when this time our A is 212 and our D is 5. So we're going to say 212 is divided by 5. All right, so my A once again is 212 and my D over here is 5, just indicating that. So remember, you're going to say A, which is 212. We're going to divide 5 into that, and we want to find what the quotient is, plus the remainder here. So how many times does 5 go into 212? I believe 5 goes into 212 42 times? Let's see. 212 divided by 5. Okay, it's like 42.4. So it goes in 42 times. And we're going to take 212 minus 5 times 42. So let's say 212 minus 5 times 42. And you get a remainder of 2 over here. So that means our quotient Q is 42, and our remainder is 2. Again, okay, we get a remainder of 2 again. Notice that the remainder is greater than or equal to 0, and the remainder 2 is less than 5, the D. It's important. All right, that's a number 2. Let's do a number 3. Oh, I did the wrong thing again. Write with the pen, please. Now this time we want to take a negative number. Negative 116 is going to be divided by, we're only going to divide by positive divisors by 7. So remember how that works. You take the A, which is negative 116, equals the D, 7, and you're going to have, that's going to be times the quotient plus the remainder. So let's do that in our calculators. Negative 116 divided by 7. That's going to give you about negative 16.57. Well, we want to actually use the floor function. So negative 16.57, when we use the floor function, is going to take us down to negative 17. So our Q is going to be actually negative 17. So what we're actually going to do, we're going to get rid of that 7 times negative 17 on the right side. So we're going to subtract 7 times negative 17 from both sides of the equation, which is really adding 7 times positive 17 to both sides. So basically what you want to do in your calculator, you want to take negative 116 and you want to add 7 times 17. And you'll get 3, so that'll be what your remainder is, 3. So your remainder should always be positive or 0. Yeah, it should always be greater than or equal to 0, and in this case, less than the divisor 7, and it is, right? So our Q is negative 17. So Q is allowed to be negative, but R is not allowed to be negative. Remember, R has to be greater than or equal to 0, and less than, in this case, the divisor 7. That's how you do a negative A situation, when the A is negative. Let's do another one where the A is negative. So our D's are always going to be positive, but our A's can be negative. So let's do minus 307 divided by did I write the word by last time? I don't think I did. Yeah, divided by 8. So my A here is minus 307. That's going to be equal to 8 times some quotient Q plus some remainder R. So let's take negative 307, divide that by 8. I get negative 38.375, so I'm going to use the floor function. I'm going to put minus 39 for my quotient. And basically what we're going to do to both sides, we're going to add 8 plus 39. So right, we're actually subtracting 8 times negative 39, but the same thing would be adding 8 times positive 39. So we're going to take minus 307 plus 8 times positive 39, and we get a remainder of 5 here. So the quotient is a negative 39, and the remainder, R, is 5. Now notice that R is greater than or equal to 0, and it's strictly less than the divisor of 8. All right, we'll do one more. Now number 5, minus 208 is divided by 4. Let's find the quotient and the remainder. So I'm going to take negative 208 is my A, equals my divisor D, which is 4, times the quotient, we got to find that, plus the remainder, we got to find that. So if I take negative 208 and divide it by 4, I should get minus 52. And it comes out evenly to minus 52. So the remainder here is actually going to be 0. No remainder at all. Well, there is a remainder at 0. So that's perfectly good to have a remainder of 0. Remember that your remainder can be 0, right? If you go back and you look here, remember the remainder here has to be greater than or equal to 0. It could be 0, and strictly less than the divisor, which in this case is 4. So we got the quotient is minus 52, and the remainder is 0. Okay, so that's using the division algorithm. Using the division algorithm. We'll just stop there, and in the next video we'll check out some modular arithmetic, congruence mod M, and modular arithmetic.